I come from Dispelix, which is a Finnish company doing see-through displays for augmented reality glasses. So we are a fabless designer and supplier for augmented reality optical modules for glasses manufacturers and developers. This means that we are actually in the module business or component business, providing the future technology for the companies to make the end device for their segment. So we are spin out from VTT, Technical Research Center of Finland, and we spin out last year, March. Currently, we have grown very fast during this last 1.5 years, so we are already 14 people company, and we have sites in Oulu, Espoo, and the latest one in Joensuu. Where we aim to be the Intel of the optics for the next generation of consumer devices and also industry devices, providing the key technology to big companies and small companies. So first of all, I start this industrial AR by asking how many of you knows what is augmented reality? Okay, so that's very good. My first real touch with the augmented reality was with Hololens product, as maybe many of you. And it's really fun. It can be really fun. It can be very useful. This is my this is actually my son with augmented reality device, Microsoft HoloLens. Unluckily, we don't have that video running, but it's really fun. And that really opens your eyes once you try it first time. You can really see virtual objects blended in your environment. And that makes a difference. And why it is such huge difference compared to what we have currently? Because now we really interact with the environment with virtual objects. And those can create amazing things, help us to evaluate. And this is the way the world will change. It will change not only how we use devices, like mobile phones in the first row. They will change into smart glasses. And why you need any more TV or this kind of screens when you have bigger image in your glasses and much better performance. So that's why there is a big estimate on augmented reality and huge bets made on that. So first of all, there is a market estimation that augmented reality hardware will be 45 billion in 2025. When we count that down, we come to around 600 US dollars a unit. And there we come the units sold annual, 75 million units. And what that means to photonics for optics? With the 2 modules, 1 module price below 50 US dollars, we came up that the market is actually 7 billion US dollars. And that's huge optics or photonics market. But that was a little introduction about the augmented reality, the market, and the area the Dispelix company is working on. So next I want to go to augmented reality a little bit more detailed and later on to industrial. So first of all, it's good to define what are the subcategories of augmented reality. First of all is the hardest one, so mixed reality, which is actually the best example is Microsoft HoloLens. And why is it a mixed reality? It means that the virtual objects interact with the environment. So it's mixing the real world and the virtual world. And the main use cases, you can of course use these at different things, but the biggest use case is gaming, entertainment. You can really be in the game. Let's say you are watching a hockey game or a football game. And then we come to some details, what is needed for that. And that's really good to understand because there is a different need for different kind of purposes. So with these kind of things, you need very large image, so huge image so that you immerse in that world. You need 3D image, some maybe even see a light field. You need 3D mapping so that the device understands the world. You need camera vision to understand what is that object and how the algorithms and software can change and then run that. And the cloud access, because there is a lot of information. Next is a little bit more simple, like smart glasses. And the main difference is that smart glasses device, like it's like a second display from your mobile phone. So you get notifications, navigations, all of those things. But when you turn your head, the image moves with you. So it's not attached in the real world. And there we see that the main functionalities, we need key things there. We can go now small or medium field of view, depending on what is the main use case. It can be binocular or even monocular. You need camera and phone connectivity to have access on internet and processing and everything. The next category is like integrated devices designed for some use case, like motorcycle, sports, hiking, swimming, whatever. And now, because it's used in some use case and it only deliver the most important things you need, so even small field of view can work, monocular can work very well, and the mobile phone can be used as a connection point. Next is the industry or work. But that varies highly. So in my presentation shortly I come to what kind of things we can see from there. And the last one is pass-through. This is now very hot, so AR kit, AR core, and that kind of things to make augmented reality on mobile phones and tablets. I see those that they are like development platform for real augmented reality glasses. So let's go to augmented reality in work and what have been done in industry for this kind of with this kind of glasses, not only tablets. So, for instance, Caterpillar, they already did remote maintenance. So there is a little breakdown in the field with their equipment. You put on your pair of smart glasses. You have a connection to help desk or technician to go through how you can do a small service or maintenance work for that equipment, and maybe get it running in just a few hours instead of days when the service guy arrives. DHL did some studies on logistics, and can they really boost the efficiency, and is it worth on logistics? And this is very interesting because they even get 25% more efficiency boost on their logistics. And I bet it was the best of the world even before. In healthcare, Google Glasses have been used to remotely assist surgeons on their work to perform a new kind of surgeon that they never had done before with some expert. Boeing, they did a wiring thing and they get 25% more efficiency in productivity. Construction, you can overlay the places you need to put this bar on a place. You can go on the construction site and see where the piping should be and everything. And in retail, it would be really nice to see where the couch should be and not to change it everywhere. Does it fit very well on my room? Do I need anything else? And that's already IKEA doing that. Hopefully shortly in glasses. So now to design the device for industry use. First of all, I use different categories. So integrated for some special use case, giving the information to the user, giving the guidance to user, and analyze the environment, giving the guidance, remote access to everywhere. So there we have to remember that each of these devices need different parameters. And for example, let's say welding helmet. Only small field of view is needed. It can be monocular, most likely. You don't need stereoscopic image. You can have it monochromatic, just to give the feedback. And connecting to a device, so let's say that welding machine or somewhere else. Can be even wire. So information, just pick and drop things. Small field of view is needed. You don't want to be hustled about the information, so you need only small field of view. Monocular can work, full color, hopefully, or is preferred. Camera to read barcodes and that kind of things, and the cloud access to software. Then on a guidance, medium field of view. Now this means that it guides through a work task. And for that, you need a bigger field of view, stereoscopic image to have the image on the same plane, camera vision to understand, and cloud access connection to help desk and everything. So, and the latest one is actually like a Hololens type of device put in the work. And there you can add environmental analysis, let's say what is the temperature of these things and everything. But the key thing is that no matter what is your use case, you design the device according to, but the software is of course a very important feature on that. So I will do this very fast. So by skipping, I'm a little bit behind. So let's go through here and see the waveguides which we are doing. So actually the waveguide, we incouple the light inside the light guide and travel it there by total internal reflection, and then we outcouple it to user's field of view. And these are the couple of examples of waveguides using exit pupil expansion. So we are doing it in a single layer combiner element. Microsoft HoloLens have a 3-layer stack, and then Lumos from Israel use cascaded mirrors. Why we do it this way? This is a very hard way to do it. There should be a more simple way to do it. So why we do it that way is because when we map the thickness of the optics and the size of the eye box, meaning what is the room for eye to move and still see the image, we can see that waveguides with exit pupil expansion is the only way to keep it very thin, lightweight, and have it a good form factor, even for work. And this is see-through image taken through our waveguide. We will be launching something very interesting next year and giving you more information later of this year. But I want to thank you, and I'm ready to have some questions.
Thank you, Antti. It was a very nice presentation. So this is a very hot topic currently. So probably we have a lot of questions here. Who will start? Okay. Mennään vaan logistisesti.
Hello, Jani Holopainen, Helsinki University. We are actually making studies on customer value with the mixed reality environments. And my question is that have you been involved in some kind of research project perhaps, or there was a very interesting statistics that you showed on the DHL, and I know that that's one of the few studies that actually exist which is not even from the academia, but your background being in a VTT, so have you had any chances to get involved in customer value studies in relation to augmented reality technologies?
Yeah, you're right. There is not that many academic papers on customer value on augmented reality, and there is some company like DHL and Caterpillar things Boeing released, but not. We haven't been actually active on even the times we were at the VTT for these kind of studies. So no, I haven't been. But there is another group in VTT which have done these kind of things.
This may sound a bit stupid question, but I'm the generation that who's get used that don't watch TV too close. So about those glasses, how difficult it is for eye to get used to picture which is very near?
Yeah, that's a good question. So actually, even though the waveguides are very close, or the optics is very close to eye, and in our case and in all of the waveguides, the image is actually formed first time at the retina. So there's no image at the plane on that, and the focus is at the infinity, which means that it's very bright and crispy and good resolution after 2 meters of focus, and that's way the eye can see it with the relaxed states. I don't need to. My eye or the user's eye don't need to do any work to see the image.
You're welcome to test the technology. We have a demo outside.
Markus Melander from Vionize. What kind of cooperation or joint R&D you would like to have with the Finnish forest industry, for example?
Yeah, I see a lot of potential on Finnish forest industry on augmented reality. It can play a huge role on the operator of the device, or putting up the equipments like the harvester or anything, maintenance of them, and really boost the efficiency of the workers, and this way create more value to the companies working in Finland. We can supply these modules to be integrated if they have an interest of doing their own devices.
Yes, hello, Jukka Kurkinen from Kesla. You mentioned about these examples from Caterpillar and Boeing, and especially from the Boeing side in assembly, there was a remarkable efficiency boost. Can you elaborate a bit how they actually did it? brought the benefit?
Yeah.
Can you say it?
That was done for the wiring of the airplane. So there is a huge stack of wires, and you have to connect these very well together, and each one have the right one connection. So it used to be that the worker had a lot of papers, just go and check, okay, blue, or check the connections, each one. But now the glasses have the information all the time, so they don't need to look away to see the guidance or the prefer how they used to do it, but they have a guidance already all the time in their field of view. And that gave the huge benefit on the work.
I have another one. Yes, I think we could discuss a bit longer also about this topic, but one more question. Can you say what does it require to have this kind of capability in place? Is it like what kind of components you have to actually do or develop or this kind of stuff?
Yeah, actually all the components are there. So it's engineering work and very well defined where it will be used. And there is a companies you can outsource the putting up the device, all the components, and we can help on the optic side, see-through display side. But the main thing and the big thing is of course the software, how it integrates and how well in the existing systems you have or the company have. So that's one big part of the devices, of course.
Kimmo Solemainen from VTT. So in order to become the Intel of AR, so what are the main bottlenecks? Is it like still develop components, manufacturing technologies, or more like finding partners or developing applications, so forth?
Yeah. For us, because we are supplying the modules or for the devices, it's about our customers and what kind of devices they will launch and in what time frame. And we have a good collaboration ongoing with many partners currently. It's about the content and everything, especially in consumer business. But we already see that the content is being created by using this AR kit and AR core and Microsoft HoloLens device. A new kind of content, new way of using the entertainment or using the devices is actually being done and created currently. I will see that in very short future we will see many devices coming from big players, consumer electronic companies. And that will open the market, and we are ready for that.
So Antti, can you give me some comments about this photonics and AR development situation in Finland? So how good we are we leading, are we far from others? So can you describe the situation in Finland?
Well, the Finland is leading on the see-through displays actually, thanks to work Nokia done a long time ago. They were a little bit early on that things, but that really elevate the Finnish industry. And of course we have the University of Eastern Finland, which is a very good education on this area, how to manufacture, how to design these devices, these see-through displays. So there we are actually a top leading country on that side. On other devices, we have very good on photonics and different devices, and a lot of startups ongoing. Vario with VR devices, having human resolution, spectral engines with the sensing of the materials next to you, giving the spectrum from those very small form factor. Ladimo doing the 3D mapping of the environment. So we are very good in Finland on this photonics and the next generation to be.
Yeah, it seems that so is a possibility to forest industry to do cooperation.
Yeah, and that's of course because we have all of these in Finland. It's a good opportunity for forest industry to integrate these.